Hey Braves, I wanted to go over a quick assignment with you. The momentum simulation assignment, I can't imagine can be a little confusing because the only thing you have to go on is written instructions. And even for somebody like me, who's been reading instructions like that my whole life, sometimes it can be a little confusing when I read things and I only have written to go off of. So the easiest thing to do for this assignment is to just show you what to do. And once you kind of see what to do, this is a super simple assignment. It's like a plug and chug assignment, basically. So once you get the process down initially, boom, you just repeat that process over and over until you're done. It's getting over that first hump of figuring out how to do it correctly the first time. And hopefully that's what I'm going to do here. I do apologize for the glare here. This is like the best place in my house to record this. So, I'm going to be making squinty face the whole time. So I apologize for that. All right, let's go ahead and get into this. So this assignment is due on Thursday, which is December 3rd. If you want to know the very last day that you can turn that in, it would be next Thursday. That's 7 days later. So, you've got until technically next Thursday to get this in and still get credit for it. All right, you click on this and it's a Google Doc. And here's your Google Doc. And your objective really is to be able to calculate momentum. That's really what I want you to be able to do. And I kind of want you to get a sense for what momentum is. It's a very simple concept. And I think most of you kind of get it. But what we're doing here is not just being able to understand it, but be able to explain it and be able to predict certain things based off of what we know your momentum is. Okay, so this is like one step deeper than just understanding. So that's why we're doing calculations here. So you can start to kind of see the relationships of how each of the variables affect your overall momentum. The two variables of momentum are your mass and your velocity. You multiply those together and you get your momentum. Now they have to be in the right units. So really the hardest part about this is just getting it to the right units. And then after that, you just multiply the two numbers together and boom, there's your momentum. But I want you to do some calculations here to kind of see how if I change mass this amount, well, what happens to my momentum? If I change my velocity this amount, what happens to my momentum? And I'm just trying to get you to kind of see those relationships. And sometimes the best way to do that is calculations. So, okay, you have a simulation to do. The simulation is right here. When you click on this link, it takes you to this, and you get two little carts to experiment with. So I'll go ahead and pull up the full screen so you can kind of see it. Move my head out of the way here. Okay, so you have two carts, and you can set them to 1 kilogram, 2 kilogram, or 3 kilograms in mass, and you can set their velocities either positive or negative 10, and different amounts in between. I think it's 1 meter per second intervals there. Okay, so if I hit reset, I get my carts back here, and I start off where my one cart is going 5 meters per second, and my second cart is going -5. That's because it's going this direction. That's what it means by negative. So positive would be going right, negative would be going left, all right? We're thinking of it in terms of like a grid, and you can see they even put grid paper back here to remind you that we're thinking in terms of a grid. So there you go, all right. So what I do is I set the initial conditions. I want to make sure it says elastic collision. It will actually change the results if you select one of these others. So make sure you're using elastic. And then you hit start. And you notice there's your velocities, and nothing changed except for this one went from 5 to -5, and that one went from -5 to 5. Change some more variables. So the first part of this assignment is simply to play around with the different variables you can and just kind of watch what happens. So you can go ahead and go back here, hit reset. Maybe I turn it to 1 meter per second and -5, and let's see what happens. And they collide, boom, and you see a result. Okay, so you can play with that for a little while until you get used to using it. Now, the actual assignment portion of this is for you to go and use this table and figure out some information, some important information. To give you an example here, we'll just go ahead and do the first one. My object 1 and object 2 both have 1 kilogram of mass. So, okay, I got them both set on 1 kilogram. I'm good. All right, object 1 initial velocity, that's the red cart, I want it to be at 5. Okay, so I'll turn it up to 5. And I want the blue cart, object 2, to be -5. Okay, that's -5. I run the simulation. Initial velocities, and now we're in the final velocities. So the final velocity for the red cart was -5, and that's what I put here. The final velocity for the blue cart was 5, and that's what I put there. So then I would go back and I would do this again for trial 2. Trial 2, I want my mass to be 3 kilograms for the red car. So that one. And I want it to be the same 1 kilogram for the other car, so it's not going to change for that one. And now we're going to keep the velocities the same, so 5 and -5, just like the last time. So those don't change. All right, let's go ahead and run it and see what happens. They collide, walk. Whoa, something different happened this time. Instead of it being 5 and -5, it went from 0 and 10. So the blue cart apparently acquired all of that momentum that was in the red cart, and it was transferred over to here. So let's go on ahead and write those numbers down. Boom, 0 and 10. You'll do this for the next 3 trials. So I just gave you the first 2 right off the bat. That brings you down to part 3. So once you change the variables, go through that the next 3 times, you fill those out. Okay, then that gets you into part 3. So what you're going to have to do is you have your final velocities here. You have your masses here. After you've filled out this table right here, all the way down to part 5, when you get to part 3 on chart 2, you are going to calculate the final momentum for each object. So in this instance, it was 1 times the final velocity 5, -5. Well, and that gave me -5
kilogram meters per second.
For the final momentum for object 2, I would take my final velocity here, and I would multiply it by my mass, and that would give me my final momentum. Now it was 1 times 5 and 1 times -5, so that was easy. Let's do the other one. So my final velocity for object number 1, this guy right here, I would fill that in right here. And how do I do that? I take my final velocity, so it was 0. I stopped moving, if you remember. And I multiply that by my mass, which was 3. Well, 3 times 0 is 0. So I would have a 0 kilogram times meters per second. Okay, that would be my final momentum for that one. Then my final momentum for object number 2, I got to go do that calculation. So it's 10 meters per second was my final velocity, and my mass was 1. 1 times 10 is 10. So math pretty easy there too. This would be 10 kilograms per meter squared. There. Now, you can see that that's how you fill out these right here. So then how do you get the total initial momentum and the total final momentum? Well, you're going to have your final momentum for object 1. You're going to have your final momentum for object 2. And if you look, the total final momentum here is just object 1s plus object 2s together. So to find this right here, all you have to do is add this number to that number. So if I add -5 to 5, I get 0. So that was a total final. Okay, well, how do I get my initial? Well, thankfully, that's been given to you. So if you look, object 1 initial momentum, object 2 initial momentum. And look, total initial momentum equals object 1's initial, object 2's initial. So to get the initial momentum for this one right here, I take 5 and I add -5. That equals 0. So 5 plus negative 5, 0. Negative 5 plus 5, 0. That's how I get that. Okay, what about the next one? 15 plus negative 5 gives me 10. All right. And then what about the total final? Well, I just calculated those. So that's 0 plus 10. And that gives me 10 kilograms per meter per second. So that's how you go about filling out these two charts. So I basically just did the first two for you. Now all you have to do is the last three for each of these tables. These questions here are just getting you used to looking at the numbers and trying to figure out what those numbers are telling you. So when you are looking at these, you can see there's hints like compare the crash in trial 1 versus the one in trial 2. Just trying to get you to look at your table, compare the numbers, and maybe think about what's going on there. What's the relationship? Is there a relationship? What did you notice about the objects that had a higher initial velocity? So some of these, you held the mass the same, but you had higher velocities to start off with. Was there a pattern? Did you see a trend? Did you see something happen over and over again? Like, that's what we're asking you. Are you seeing some sort of a ratio or something like that? Some sort of a relationship? Is it proportional? Is it directly proportional? That's what we're asking. So these last questions are just there really to kind of get you guys thinking about what these numbers mean and what that means for momentum. So that's how you do this assignment. Fairly simple. Once you're done, just hit the turn in button, and yeah, I'll go about grading it and giving you your due grade. All right. Hope that was helpful. I'll catch you guys later.